For decades, Venus was thought to be a dead world, a silent, scorched twin of Earth. But what if the planet is still alive, erupting, reshaping itself in ways we could barely imagine? Did scientists just uncover proof of active volcanoes on Venus? Chapter 1. The Shrouded Planet. Imagine standing on the surface of a world that feels both familiar and alien. The ground is solid rock. Mountains rise in the distance, but the air is crushing, so heavy that it would flatten you instantly. The temperature is hotter than an oven, enough to melt lead. The sky is not blue, but a permanent haze of yellow and orange. This is Venus, Earth's twisted twin. For centuries, Venus has been a mystery. Through telescopes, all we ever saw was a smooth, featureless ball wrapped in clouds. Unlike the Moon or Mars, no craters or valleys could be seen. Just a pale disk in the night sky. Those clouds were beautiful, but they also acted like a mask. They kept the planet's true face hidden. Scientists could only guess what lay beneath. The little we did know was frightening. Venus is almost the same size as Earth. It could have been another home, a second cradle for life. Instead, it became something very different. The surface temperature is around 465 degrees Celsius, hotter than Mercury. Even though Mercury is closer to the Sun, the atmosphere is almost all carbon dioxide, with thick clouds of sulfuric acid drifting across the sky. The pressure is 90 times stronger than Earth's, the same as standing a kilometer under the ocean. Nothing we know could survive there. This makes Venus very different from Mars. Mars is cold, dry and dusty, but at least it allows machines to land and keep working. Rovers roll across its deserts, taking pictures, drilling rocks, and sending data back home. Venus, on the other hand, destroys anything we send. Soviet landers in the 1970s and 1980s lasted less than 2 hours before the heat and pressure broke them apart. Cameras melted. Electronics failed. One by one, they went silent. It's as if Venus doesn't want us to look. It's as if the planet is keeping its secrets locked behind that wall of toxic clouds. And for decades, those secrets remained hidden. Scientists could only speculate. Was Venus once like Earth, with oceans and rain? Did it have rivers, continents, maybe even life? Or has it always been this way, a furnace world, shaped by endless volcanic eruptions and a runaway greenhouse effect? Because we couldn't see the surface directly, every answer felt out of reach. Ordinary light cannot pass through the thick Venusian atmosphere. No telescope on Earth, no camera in orbit, could show us what the ground really looks like. In a sense, Venus became a kind of forbidden world, so close to us in the solar system, but always out of reach. Yet this veil of mystery is what makes Venus so fascinating. It's not just another planet, it's Earth's sibling, born from the same cloud of gas and dust, almost the same size, orbiting the same sun. But somewhere along the way, the two worlds took opposite paths. Earth became a home for life. Venus became a warning, and that warning feels personal. Scientists often call Venus a mirror of Earth's future. If greenhouse gases rise too high, if our climate spirals out of control, Earth could one day resemble its neighbor, hot, uninhabitable, lifeless. Studying Venus is like studying a future we hope to avoid. But before we can learn those lessons, we need to uncover the truth. We need to know what really lies under the clouds. What is the surface made of? Is it flat, mountainous, volcanic? Is the planet still changing, or has it been frozen in time for millions of years? These questions drove scientists to find new ways of looking. Since visible light couldn't pass through the atmosphere, they turned to a different tool: radar. Radar waves can pierce the clouds, bounce off the ground, and return to receivers. From those signals, computers can build a picture. Not a photograph, but a detailed map. This was the beginning of a revolution in our understanding of Venus. And it all started with one spacecraft, Magellan. In the early 1990s, NASA launched the Magellan mission to orbit Venus. Its goal was simple but bold: to map the surface with radar and finally reveal the hidden face of the planet. Over 4 years, Magellan circled Venus again and again, sending back millions of radar echoes. Bit by bit, those echoes turned into a global map. For the first time in human history, we saw Venus not as a smooth yellow ball, but as a real world, What the map revealed was both beautiful and terrifying. Volcanoes taller than Mount Everest, endless lava plains stretching for thousands of kilometers, strange circular structures called coronae, like giant scars across the surface, and craters but far fewer than expected, suggesting the surface was younger than we thought. This was not a dead world. It was scarred, restless, and violent. Venus looked less like a sister planet and more like a catastrophic version of Earth. Still, even with the Magellan data, mysteries remained. Were those volcanoes ancient ruins, or could they still be active? Was the surface frozen in time, or still shifting beneath the clouds? The maps showed us the scars, but not the heartbeat, and so the question remained, hanging in the air like the planet's own toxic clouds. Is Venus truly dead, or is it alive? Chapter 2: The Magellan Legacy. When scientists realized that telescopes could never reveal the surface of Venus, they turned to a different kind of vision: radar. Radar is not blocked by clouds the way visible light is. Instead, it bounces through the haze, hits the ground, and comes back. By measuring how those signals return, computers can build a picture of terrain that would otherwise be invisible. This idea was powerful, but turning it into reality required a spacecraft. In 1989, NASA launched the Magellan mission aboard the space shuttle Atlantis. A few months later, Magellan entered orbit around Venus. Its purpose was simple but historic: to map the entire surface of Venus using synthetic aperture radar. For 4 years, Magellan circled the planet again and again. Each pass collected new strips of data, like slowly peeling back the mask of clouds. Eventually, it mapped about 98% of Venus' surface, the most complete view humanity had ever achieved of our mysterious neighbor. The results were stunning. For the first time, we saw Venus not as a featureless ball, but as a living landscape. The maps showed mountains higher than Everest, endless plains of hardened lava, twisted valleys, and strange circular features called coronae. These coronae, sometimes hundreds of kilometers across, looked like gigantic scars, perhaps formed by magma pushing up from below. The most striking discovery was the sheer number of volcanoes. By some estimates, Venus has more volcanoes than any other planet in the solar system, possibly hundreds of thousands of them. Shield volcanoes, lava domes, collapsed craters, vast lava flows. The planet looked like it had been shaped, over and over again, by fire. At first, scientists were cautious. They admired the map, but assumed much of this activity was ancient. The lack of small impact craters suggested that the surface had been repaved sometime in the last 500 million years. Lava had flowed across the land, wiping away older craters and creating a relatively young surface. But when that resurfacing happened was a mystery. Many thought it was a one-time event, massive volcanic floods long ago, after which the planet became quiet. In other words, Venus was considered dead, violent in the past, but now frozen. No eruptions, no tremors, no movement, just silence under the clouds. But even as these conclusions were drawn, Magellan was still collecting clues. Its radar data was detailed enough to show small changes in topography, and the spacecraft made multiple passes over the same areas. Those repeated scans created an archive, a treasure chest of information. At the time, computing power was limited, and researchers focused on making the first global map. But the raw data was stored carefully, waiting for future eyes and better tools. This is where the legacy of Magellan becomes fascinating. It wasn't just a mission of the 1990s, it was the creation of a time capsule. Hidden in the radar echoes, in the slight differences between passes, were hints that Venus might not be as dead as people believed. Imagine this: you take 2 photographs of the same landscape, years apart. At first glance, they look identical. But if you study them closely, pixel by pixel, you might notice a building that collapsed, or a river that shifted. That's essentially what Magellan offered. Radar snapshots of Venus's surface, separated by months, sometimes by years. Back in the 1990s, nobody had the computing power or the algorithms to compare them in detail. But decades later, with new technology, scientists could return to this archive and ask fresh questions. The foreshadowing was clear. What if those volcanoes weren't just relics? What if the surface had changed in the short window Magellan was watching? What if Venus was still active? The thought was thrilling but also unsettling. If Venus is geologically alive, then its atmosphere, already dense with carbon dioxide, might still be fed by eruptions. That would make the planet's climate even more extreme and help explain why its atmosphere is so thick. It would also mean that Venus is not just a fossilized planet from the past, but a world in motion. At the time, though, the scientific community preferred caution. With no smoking gun evidence of eruptions, the consensus remained: Venus was dormant. The volcanoes were monuments to an ancient past. But some researchers weren't satisfied. They kept returning to the Magellan data, looking for inconsistencies. Why were some areas smoother than others? Why did certain features look distorted in repeat passes? Could these be signs of geological activity, hidden in plain sight? Magellan had done its job. It revealed a world scarred by fire and reshaped by forces no one fully understood. And though it was deorbited in 1994, burning up in Venus's atmosphere, its data survived. Thousands of gigabytes of radar echoes were stored, waiting in digital vaults. For most people, Magellan was just a chapter in space exploration history. But for scientists who believed Venus still held secrets, it was the beginning of something much larger. Because data doesn't age, clues don't disappear. They only wait for someone to notice them. And decades later, as researchers applied new analysis techniques, the waiting was finally over. They began to find subtle but undeniable changes, features that had shifted, vents that had grown larger, patterns that only made sense if magma had been moving beneath the crust. Suddenly, the story of Venus changed. Magellan, once thought of as a closed book, became a key to a mystery we are still unraveling today. It is a reminder that exploration is not just about the moment a spacecraft flies, but about what happens afterward. Sometimes, discoveries are waiting in old files, hidden in the noise of data collected long ago. All it takes is patience, curiosity, and the belief that a dead world might still be alive. So when we speak of the Magellan legacy, we are not just talking about a spacecraft. We are talking about a gift left for the future. A warning carved into the surface of Venus, visible only to those willing to look again. The question that now echoes through planetary science is simple but profound. If Magellan showed us scars of the past, did it also record the heartbeat of the present? That question leads us directly to the next chapter of this story: the strange signals in Magellan's radar data that may prove Venus is not silent at all. Chapter 3: The strange signals. For decades, Venus's volcanoes were treated like fossils, dramatic but silent. The global map from Magellan showed a world covered in volcanic scars, yet scientists assumed they were remnants of a violent past, frozen in time. But science has a way of surprising us, especially when old data is given a second look. In recent years, planetary scientists decided to return to Magellan's radar archive. Armed with new computing tools and sharper algorithms, what they found would rewrite the story of Venus. The discovery began with a careful comparison of radar images taken months apart. Remember, Magellan orbited Venus for years, scanning the same regions again and again. Each pass gave another angle, another slice of data. To most researchers in the 1990s, those differences were just noise, distortions caused by the spacecraft's changing orbit. But to a new generation of geologists, they were an opportunity. One research team focused on a particular volcanic vent, located in the planet's northern highlands. When they compared two sets of radar images, separated by only 8 months, they saw something extraordinary. The vent wasn't the same. Its shape had changed. Its opening had widened, nearly doubling in size. Around it, the surrounding terrain looked freshly coated, as though lava had spilled out and hardened. This wasn't an ancient scar. It was new. It was alive. On Earth, such a change would be unmistakable evidence of a recent eruption. And on Venus, where no atmosphere could erode rock in just months, the conclusion was unavoidable. This volcano had been active during Magellan's mission. It was a revelation. For decades, Venus had been labeled geologically dead. Now, here was the smoking gun, a vent that had grown larger in real time, captured by Magellan's radar. But that was only the beginning. As scientists combed through more of Magellan's data, they noticed additional anomalies. In some regions, circular features called coronae stood out. These were vast rings and domes in the crust, sometimes hundreds of kilometers wide. They looked like blisters, as if something from deep inside the planet had tried to push upward. Geologists believe coronae are formed by plumes of magma rising from the mantle, distorting the surface before either cooling or erupting. On Earth, we see smaller analogues in places like Hawaii or Yellowstone, where hotspots punch through the crust. On Venus, however, the scale was breathtaking. Coronae so large they dwarfed anything we know on our planet. What truly caught scientists' attention was the condition of these coronae. Some looked relatively fresh, their edges sharp and unweathered. Others appeared older, softened by time. The distribution suggested that these features weren't all ancient relics. Some might have formed recently, even during the time frame of Magellan's mission. Taken together, these observations painted a picture of a planet in motion. Not silent, not fossilized, but restless, breathing, shifting, reshaping itself beneath the clouds. The dramatic point is this: the changes could not happen on a dead planet. For a world once thought to be a geologic graveyard, Venus was suddenly behaving like a living world. Its surface was not frozen in the past, but actively evolving. This realization electrified the planetary science community. If volcanoes were erupting today, then Venus might still have the same kind of deep internal engine that drives plate tectonics and volcanism on Earth. And that changes everything. First, it means Venus's atmosphere is not just a static blanket of carbon dioxide left over from ancient times. Fresh eruptions could be pumping gases into the air right now. Sulfur dioxide, carbon monoxide, even water vapor in tiny amounts. That would help explain some of the strange variations scientists have detected in Venus's skies over the years. Second, it redefines the planet's identity. For decades, Venus was nicknamed Earth's evil twin because it is similar in size and mass but utterly hostile, with crushing air pressure, searing heat, and acid clouds. But if the planet is still geologically alive, the twin metaphor becomes even sharper, because beneath all its differences, Venus may share the same restless heart as Earth. Think about that for a moment. Two planets born in the same neighborhood of the solar system. One developed oceans, life, and continents that drift across its surface. The other became a greenhouse inferno, yet may still rumble with volcanic fire. Twins, yes, but twisted into very different fates. For scientists, the implications are thrilling and unsettling. Active volcanoes on Venus mean its interior is still hot and dynamic. That suggests the planet has not completely shut down geologically, as Mars mostly has. Instead, Venus might be caught in cycles of resurfacing, periods when eruptions cover vast areas in lava, reshaping the world in geologic blinks of an eye. The thought is both fascinating and disturbing, because if Venus can stay active under such extreme conditions, what does that say about its long-term future? Could it be on the edge of another catastrophic resurfacing right now? Could the entire surface be preparing for another flood of lava that would erase craters, mountains, and valleys in a single planetary upheaval? Magellan's data doesn't answer these questions, but it gives us hints that the story of Venus is far from over. What we do know is this: in just 8 months of observation, one vent changed visibly. That alone is enough to confirm Venus is not dead. Multiply that by thousands of volcanoes across the planet, and the possibilities are staggering. It forces us to see Venus not just as a static hellscape, but as a world of ongoing drama, unpredictable, dynamic, alive. This realization has also fueled new missions. Space agencies now view Venus not as a closed case, but as an active laboratory for planetary science. Missions like NASA's upcoming VERITAS and DAVINCI, or Europe's Envision, are designed with one goal in mind: to find out just how alive Venus really is. They will carry far more advanced radar and imaging systems than Magellan ever had. They will peer through the clouds, measure the gases, and watch for signs of eruptions in real time. And when they do, we may finally answer the haunting question: is Venus erupting right now, as we speak? For now though, we only have the strange signals left behind by Magellan. Radar echoes that whispered a truth too bold to believe in the 1990s but undeniable today. Venus is not silent. Venus is not dead. Beneath its suffocating clouds, the planet moves, groans, and erupts. And that means Earth's so-called evil twin may be more like us than we ever imagined. Not because of life, not because of oceans, but because of its restless, unpredictable heart of fire. Chapter 4. Why it matters. Venus has always been a riddle. For decades, scientists looked at it as a planet that had burned out long ago, a silent, volcanic graveyard covered in ash and clouds. But the evidence of active volcanism changes everything. It shifts Venus from being a relic of the past into a world that is still evolving, still reshaping itself in real time. And that truth carries consequences that ripple far beyond the boundaries of our solar system. When geologists confirmed that volcanoes on Venus were not dormant fossils, but active giants, the first question was obvious. What does this mean for the planet's atmosphere? Venus is cloaked in a dense shroud of carbon dioxide, with pressure on the surface strong enough to crush a submarine and temperatures hot enough to melt lead. For years, the prevailing explanation was that this atmosphere was simply left over from ancient eruptions, a fossilized blanket of CO that had never thinned. But if the planet is still erupting, the story changes. Every fresh burst of volcanic activity would inject new gases into the air, fueling a cycle that keeps the atmosphere thick and hostile. The choking clouds may not be remnants of a past apocalypse. They may be breathing proof of an apocalypse that never ended. In this sense, Venus is not a corpse. It is a furnace, still burning from within. This realization reshapes our theories of planetary evolution. Earth and Venus began as twins, similar size, similar composition, born in the same cosmic neighborhood. But their paths split in catastrophic fashion. Earth cooled, developed oceans, and stabilized into a haven for life. Venus, by contrast, spiraled into chaos. If its volcanoes are still active, then the divergence between the two worlds is not just ancient history, it is a process still unfolding. Venus is locked in a battle between its crust and its atmosphere, a feedback loop of fire and gas. The comparison raises a haunting question. Could Earth ever follow the same path? On our planet, volcanoes release carbon dioxide too, but the gas is usually balanced by oceans and life, absorbed, recycled, neutralized. Venus shows us what happens when that balance collapses. Imagine Earth's volcanoes releasing CO at a rate that outpaces forests and oceans. Imagine the atmosphere thickening, trapping heat, until the oceans boil away. That is the nightmare scenario scientists call the runaway greenhouse effect. Venus is the ultimate warning of how far that process can go. And here's where the science begins to bleed into something that feels like science fiction. Picture Venus not as a static world, but as a planet alive with fury. Beneath its permanent clouds, volcanoes erupt in silence, glowing rivers of lava carving across the land. Every eruption feeds the storm above, clouds thickening, lightning crackling through the acid rain. The entire atmosphere becomes a storm machine, powered by fire from below. To orbit Venus is to circle a living inferno, a world that looks peaceful from afar, but up close reveals the violence of a planet in constant upheaval. Scientists sometimes describe Venus as Earth's evil twin, but perhaps that title doesn't go far enough. If these eruptions are real, and all evidence points that they are, then Venus is more than just a twin. It is a mirror showing us what could have been, or what might still become. It's not just history locked in stone. It is a live demonstration of planetary doom. Why does this matter so much? Because understanding Venus could help us predict Earth's future. If Venus is releasing carbon dioxide today, scientists can measure how that affects its atmosphere, how fast it traps heat, and how stable or unstable the climate becomes. By comparing this with Earth's climate models, we gain insight into our own path. Venus becomes not only a mystery to solve, but a laboratory for testing the boundaries of habitability. And beyond Earth, the implications stretch into the search for life across the cosmos. Astronomers scanning distant exoplanets often look for worlds similar to Earth. But if active volcanism can keep a planet shrouded in heat-trapping gases, then perhaps many Earth-like planets are more like Venus than we'd care to admit. The galaxy might be filled with beautiful blue dots that, on closer inspection, are actually toxic worlds consumed by fire. There is also the question of time. If Venus is erupting now, then it hasn't settled into geological death yet. How long can a planet rage like this before finally cooling into silence? Could Venus burn for another billion years, or will it collapse into something stranger? A world reshaped so many times by fire that it becomes unrecognizable, even compared to today. Each question makes Venus feel less like a distant world, and more like a story still being written. The clouds no longer hide a dead landscape. They conceal a world in motion, its surface reshaping itself in ways we can barely detect. That sense of hidden activity transforms the way we view not only Venus, but the solar system itself. These are not static planets locked in eternal silence. They are actors on a stage, each with a role in a cosmic drama we are only beginning to understand. For centuries, we looked up at Venus and saw a featureless star in the sky, a point of light with no detail. Today, thanks to spacecraft, radar, and relentless curiosity, we know better. We know there is fire under the veil. And that knowledge matters not because it makes Venus stranger, but because it makes Venus familiar. In its fury, we see a reflection of Earth's fragility. In its storms, we hear an echo of what could one day be. And perhaps that is the most unsettling truth. Venus is not alien. Venus is a possible future. Chapter 5. The Future of Discovery. The story of Venus is far from over. In fact, some would argue that it is only just beginning. For decades, this world has taunted us from behind its suffocating veil of clouds, hiding its surface and its secrets. We now know that it may not be the barren, silent wasteland we once imagined. Instead, it might be alive, restless, and still reshaping itself through the fire of active volcanoes. But to confirm that truth, we will need more than hints, more than reanalyzed radar maps. We will need fresh eyes on Venus, and those eyes are finally coming. NASA has set its sights back on Earth, a so-called evil twin, after decades of neglect. For nearly 30 years, missions to Venus have been rare, overshadowed by the glamour of Mars and the icy moons of Jupiter and Saturn. But the recent evidence of volcanism has changed the game. Suddenly, Venus is no longer a closed case. It's a mystery demanding answers. And two ambitious missions, VERITAS and DAVINCI, are preparing to rise to the challenge. VERITAS, mapping a living world. The VERITAS mission, short for Venus emissivity, radio science, INSAR topography, and spectroscopy, is designed to peel back the clouds and give us the most detailed view of the planet's surface ever attempted. Using powerful radar, VERITAS will map Venus with exquisite precision, revealing how its mountains, valleys, and volcanoes have shifted over time. Imagine being able to track subtle surface changes, a vent widening, a lava flow spreading, or even the ground itself rising as magma builds below. That is what VERITAS hopes to capture. For the first time, we might watch Venus move in near real time. The planet will no longer be a static photograph frozen in data from the 1990s. It will be a living map, a dynamic landscape where every tremor tells us something about the forces inside. VERITAS will also look for the chemical fingerprints of volcanic rock. Fresh eruptions tend to expose unweathered minerals, brighter against the background of an older, darker crust. By spotting these anomalies, scientists can pinpoint recent volcanic activity, perhaps even eruptions that happened just years or months before the spacecraft's arrival. DAVINCI, a descent into the inferno. If VERITAS is about seeing the big picture, DAVINCI is about diving straight into the fire. The deep atmosphere of Venus investigation of noble gases, chemistry, and imaging mission, DAVINCI for short, is designed to plunge through Venus's thick atmosphere, sending back data as it descends. The descent probe will sample the gases layer by layer, measuring how the atmosphere is built, how it circulates, and what elements are hiding within it. For decades, scientists have debated how Venus's atmosphere became so thick, why it retains so much carbon dioxide, and whether water ever played a role in its early history. DAVINCI may finally answer those questions. Picture the probe falling slowly through clouds of sulfuric acid, its instruments straining against heat and pressure. It will transmit images as it descends, giving us the closest look we've ever had at the surface. Not just radar outlines, but photographs of mountains, plains, and possibly even lava flows stretching into the distance. By the time it reaches the ground, it may not survive long, but the data it sends before being crushed will rewrite our understanding of Venus, a decade of revelations. Together, VERITAS and DAVINCI promise something we have never had before, a complete story of Venus from surface to sky. One will chart the shifting land, the other will unravel the chemistry of the air. One will show us how volcanoes reshape the crust, the other will reveal how those eruptions feed the atmosphere. And with those missions, the next decade may bring the most dramatic shift in our understanding of Venus since the Magellan spacecraft mapped it in the 1990s. For the first time, we will be able to say not just whether Venus was once alive, but whether it is alive now. This is more than an academic pursuit. Confirming active volcanism on Venus would reshape our theories of planetary habitability, influence how we model exoplanets, and even sharpen our warnings about climate change on Earth. Each discovery will ripple outward, connecting Venus to every other question we ask about life, survival, and the future of worlds like ours. The human imagination. Of course, the science is only part of the story. Venus has always lived in the human imagination as a world of extremes, glowing in the evening sky, sometimes mistaken for a star, sometimes feared as an omen. For ancient astronomers, it was a wandering light, tied to myths of gods and love. For modern scientists, it became a symbol of planetary ruin. Now, with these missions, Venus may transform once again, from a symbol to a place, from a mystery to a reality. The idea of watching a volcano erupt on another planet may sound like science fiction, but in the coming decade, it could become science fact. Imagine the first radar images of a glowing eruption beneath the clouds. Imagine the descent camera on DAVINCI capturing jagged rocks and fractured plains, the scars of a living world. Imagine the moment scientists confirm, without doubt, that Venus is not silent, that it is rumbling, breathing, and reshaping itself right now. That moment would not only rewrite textbooks, it would redefine our relationship with the planet next door. The closing mystery. Perhaps that is the greatest gift of these missions. They will remind us that the universe is not still, that worlds we thought we understood can surprise us. Venus is not frozen in the past. It is unfolding in the present, a planet whose story is still being written with fire and storm. And maybe, one day soon, we will watch a Venusian volcano erupt in real time, a reminder that the planet we thought was dead was never truly silent. If you found this journey into the hidden fires of Venus intriguing, consider leaving a like. It helps us bring more mysteries to light. Subscribe for future explorations, and share your thoughts. Do you believe Venus is alive, or just echoing its violent past?